So for number one, it asks us to find the area bounded by the given curves. So in our general example, we have the A and B part. Here we're going to actually have to figure out what A and B are, where they intersect. Now these two curves we can graph on our own. We don't need a calculator. Sometimes we will use a calculator. Sometimes we don't really need it. If we look at this one, y equals x squared, what's that graph going to look like? Parabola, right? Vertex at 0, 0. Whoop, everything disappeared. Alright, so vertex at 0, 0. Opening up. Pretend like that's 0, 0. And what about our y equals square root of x? What does that graph look like? Half of a sideways parabola, right? Square root function looks like that. So if we look at these two graphs together, they cut off this little region right here. All right, so that's the area we're trying to find, the area in between those curves where it's closed off. Well, in that little region, in that little yellow highlighted portion, which of the two graphs is the top function? Which one's above the other one the whole time? The red or the blue? The red is the top function, right? The blue one's going to be our bottom function. Now, over here, the blue one's above the red one, but that doesn't matter to us. We're focused in on this little region only. So in that little region, red is the top function. So when we set up our definite integral, we're going to have the top function, square root of x, minus the bottom function, which is x squared. So setting up the inside of the integral, not too tough. You just look at which one's the top function, which one's the bottom one, and subtract them. Now the a and b, we have to figure out where these two intersect to know where we're finding the area from a to what value b. So what do you think a is going to be? 0. Pretty good guess, right? Good chance of that. Well, let's figure out what the other one is and just kind of back up our answer, what we think is 0. We can do this on our calculator, but we're not going to yet. First, we're going to do it by hand. By hand, we want to figure out when are these two functions equal. We have a system of equations. They're not both lines like a lot of the systems you've dealt with before, but we can use, in this case, I would use substitution. I'm going to substitute x squared in here for y. So I want to know, when is x squared equal to square root of x? Alright, so let's go ahead and solve this. First step, we can square both sides. So we get x to the fourth equals x. That gets rid of our square root. Then we can get everything on one side, x to the fourth minus x equals 0. And then we want to factor. So we can factor an x out. So we get x equals 0, or x cubed minus 1 equals 0. So for this one, if we add 1, take the cube root, we get x equals 1. So we were right in the 0 part. And then this intersection point right here is when x is 1. Now we could do this by hand. We can evaluate this definite integral. And you may have to do that from time to time. But for now, let's just go over what we learned last week and make sure everybody knows how to do this on their calculator. We're going to do math 9. Put in our function. So in this case, square root of x, close that parenthesis, minus x squared, comma x, comma 0, comma 1. And when you have more complicated functions, it may take a little while. This shouldn't be too bad, but some of the ones we'll see later will take a lot longer. And this one, you want to try and do an exact answer. This one doesn't come out to. Actually, I think it should come out to 1/3, and there might be like a little thing, a little glitch with the calculator. But if we put this as 0.333, that's fine. But I think if we did this by hand, we would find out this is actually 1/3. But in most cases, the calculator is pretty good about that.